this in fifth hour a little bit yesterday. We kind of started, and he said, just be mindful that sometimes when you start this, there's only one of two ways you can go. So if the first way doesn't work out, try the second way, okay? So here's the deal, guys, today. There's this process known as integration by parts to help us try and find some complex integrals today. And integration by parts right here, it says the following, kids. It says integration by parts is a special method of integration that often is useful when two functions are, what's the word there? Multiplied together. Now guys, I'm going to talk about what's down here, but I'm going to kind of talk back around this a little bit when we come to what we're dealing with here, all right? It says the formula above is derived by integrating both sides of the following equation, okay? And here's what I'm going to tell you, kids, all right? There's a lot of notational things in here that we've looked at, we've been dealing with in situations like integration by substitution. But when I look at that there, I see a big, big mess. Do you guys agree with that?
Yes.
Okay. I'm just going to kind of talk you through this, and then I'm going to come back and talk about it again a second time and put it in some of the notation stuff that we've seen in the past, okay? But guys, I don't know if you remember way back in chapter 4 when we were talking about derivatives. We said there was a certain derivative that you could take of some function u times some function v. You guys remember that?
Yeah.
You guys remember what rule that was? Say it. You were going to say it. Product rule. Yep. Okay. This is kind of like saying, what's the derivative of some product? This is like saying we let u equal something and we let v equal something. Okay. Now this here says the derivative of something in terms of what variable, really? Guys, we've been really substituting for a long time. You just didn't know it. We let the first part of a function be u and the second part be v. Okay. If we take the derivative of all that stuff with respect to x, what we ended up with, watch what I have here notationally. This is really u times the derivative of the part v with respect to what? This part right here is like the uv prime that we've done in the past. Okay? Plus v times what, kids? If I said what's the derivative of u times v, do you guys remember that formula from a while back? uv prime plus u prime v. Okay? All integration by parts is then, guys, is it's basically a manipulation of the product rule, okay? So here's the deal. If I took a derivative and I wanted to work backwards from a derivative, we would take an antiderivative. Very good. Okay, so what they start saying is this then. Well, let's go ahead and take the antiderivative of this. So everything that I have up here, the antiderivative on the left has to equal the antiderivative on the right, okay? Now this part, I'm going to kind of write on this a little bit more in terms of our stuff right here. But it says integrate both sides, okay? Guys, when you have the integral of just a derivative with respect to x right here, this symbol right here and this symbol kind of do what to each other? They cancel, and we're left with just what then, kids? Okay? And so this dx is going to go away because these two would have ended up doing what to each other? Okay? So the integral and that are gone. So we're just kind of left with what on the left here, kids? U times what? That's like our original product. Now guys, what the dx is really going to do to each other here? This is gone. Now I can't say that this integral is going to take this out because it's a derivative of what? And we still have one other variable in here. Okay, so what this really becomes down here, guys, is this integral of u times what's left up here. Okay, those cancel. Plus the integral of v. What are the dx's going to do again here and here? They're going to cancel. Okay, so we're just integrating each part here. All right. So what we end up doing, guys, is rearranging. And we say the integral of the following. You see this part right here? This integral of u times dv. We get this alone by, didn't they just take this and subtract it from uv to get that part on the right? Okay. I don't care if you know this or not. Okay. Okay, well, I do kind of care what you know it or not, but the thing I really want you to understand is that this integration by parts formula is coming by working backwards from which rule of derivatives? Product rule, okay? So here's what this is all saying, guys. It's saying you can integrate a function u, and that's dv is like v prime, isn't it? You can integrate a function u v prime if you set it equal to u times v minus what? The integral of v times derivative of u, or u prime, right? Okay. So the formula expresses one integral, u dv, in terms of a second integral, v du, with a proper choice of u and v. The second integral may be easier to evaluate than the first. This is the reason for the importance of the formula, okay? So here's a helpful hint for you guys. And we'll come back to this here in a second. I want to jump up top here. You see this integration by parts formula? It says the antiderivative of u times the derivative of v is equal to what? uv minus the integral of times what? Okay, I'm going to give you a little bit better one to look at. Is that okay with you guys? I think the way that we work with derivatives, I like to put the prime stuff up there. I think that's much easier than du and dv and dt and d whatever. All right? We're going to write this as the following, kids. We're going to write this down. We are going to integrate some function, u times what we call v prime. This is the same as this part. This u stays the same. I'm just changing dv to what, kids? Which means the derivative of v, or v prime. You with me on that? This is simply going to equal then what, kids? Whoops. Yeah, this will work, I guess. This is simply going to equal u times v. That's that part of the formula. Minus the integral of, what am I going to write, kids? V times u prime. So I'm going to write it this way as u prime times v. Okay? That's what we're really looking to accomplish today. Now, guys, we've been working on substituting things, and we've said it gets a little confusing because we got to take derivatives and antiderivatives at the same time, and sometimes we go the wrong direction. That's okay. Again, I might encourage you to have 6.2 notes out if you want to help us with some of those, what direction to go. But this is really the formula I want to be using here, okay? So I'll show you how this works here on some examples, but there's a helpful hint down here, and I want to make sure we understand this helpful hint before we start. Okay, the helpful hint goes like this. If you are wondering what to choose for, what do they say start to choose for here, kids? U. Here are some places to look. First, and this kind of orders it the way it goes. The first choice is what?
Natural log.
If there's ever a natural log in there, let u equal that, okay? Natural log always going to be in there? No. All right? If there isn't one, look for a what? The inverse trig function is like arc sine, or arc cosine, or arc tangent, or something like that, okay? If there isn't one of those, then look for a what third? You guys remember what polynomials are? I'll give you an example. Polynomials like, I don't know, 6x squared plus 8x plus 4. Make sense? Okay. Finally, look for what last?
Exponential or trig.
Exponential or trig function. So there's kind of an order to this. The first thing you're kind of looking for is what, kids? Natural log if there was. If there isn't, look for an inverse trig function. If there's one of those, your next choice would probably be a what? Polynomial. Finally, look for a what?
Exponential or trig.
Exponential or trig function. Now I'm going to tell you guys right here, you may not choose correctly all the times, because sometimes the rules aren't always going to apply. But for the most part, this is going to help you choose the right way the first time. And I'm going to tell you right now, if working the first way doesn't work for you, then let the other part be you. And then go with it then. If you get into something like, ooh, I have no clue, this looks really complicated, be like, what if I switched them around? And I'll show you what I mean by that here in a second, okay? So let's go to the next page here, friends. Yeah. Are we on the first example here, kids? Okay. First example says we're going to use integration by parts to find the integral of x times the cosine of x dx. Okay. First question, kids. Any natural logarithms in that integral? Any inverse trig functions? Not normal trig functions, but any inverse trig functions in that. Okay? Any polynomial parts to a function there? Let me rephrase that. Any polynomial parts to a function there? Yes. This is like x times what? Okay. Isn't x to the first power just like x to the first plus nothing? Can't x to the first be a polynomial function? Okay, it has a degree 1, okay? Now, I would say in this one right here, let u equal the first part x. Okay? Sometimes u will be the second part. You just never know. Okay, you just never know. Alright, now guys, the way you set this up is the following. I'm going to write the formula down again up top. We're trying to find the antiderivative of something right here, and we know that integration by parts works this way. It's the integral of uv prime. That's kind of what this first part is, the integral, but we're going to call uv prime. That's got to equal what u is times v minus the integral of u prime v, like this. So guys, to get an answer over here for this, we got to solve everything over here. Basically, we've got to make this sign right here go away. But here's the situation. I've assigned u to equal what? Okay, this part of the function is really what we're starting with. So if I've assigned u to be something, I also need to assign what else then? Okay, we've got to let v prime equal something. I'm going to put v prime right here. Well, if I let u equal x in this, what's v prime have to equal? The cosine of x, correct. So talk to me here. Kids, I see u in the function up here, but are there also some u primes up here? So if I know u, if I've assigned u, we need to use that to know what else is going to be involved in this answer. Well, u prime, right? What's the derivative of 1x? Just 1. So u prime that we're going to use has to be 1. Okay, think about this. There's a v prime that we've assigned to be cosine of x. So let me ask you this question. Are there some v's up there in the formula that we're about to use for integration by parts? Okay, so we would need to know what else. What's the antiderivative of cosine? What would you take the derivative of to get to cosine?
Negative sine.
Almost. Sine, positive sine, yep. Okay. Now if you were taking the derivative of cosine, then it would have been negative sine. Right? Just more options or more opportunities to mess up, isn't there? Okay. Here's the biggie today, kids. Once you've established this right here, how many parts do I have to establish? It's a matter of plugging things in and solving. Okay? We have this part right here already. This is what we're trying to solve. This part is the original problem. The part you're worried about now is over here on the right-hand side. Okay? So our answer to this part over here in the red box is going to be the part in the blue cloud over here. Does that make sense? Let's start plugging stuff in. We're going to have u times what first, kids? Okay? And I'm going to write the whole problem out. So I'm going to say the integral of x times the cosine of x with respect to x is going to equal the following. That's the original problem, right? That's this part in red. That's the u times v prime, isn't it? X times cosine of x. Okay, here's what it's going to equal. It's going to equal u times v. So what is u times v, kids? Yep. So we're at this part right here, up top, u times v. It's going to equal u is x, v is what? Okay, this is going to equal x times the sine of x. Okay, then minus what? Of? Okay, integral of u prime times v, right, Maddie? And 1 times the sine of x is just simply going to be the sine of x. Now I'm going to do something here, kids. Sine of x with respect to x. We're not completely done. We're not done until we find, this is a bad color to choose, but we're not done until I find the antiderivative of that part. Okay? But guys, let me ask you a question about the antiderivative of that part. Does that look like a simple antiderivative or a complex antiderivative? Looks pretty simple. If you get to a part here and say, ooh, that looks really complex, pretty good chance u and v prime are probably going to need to be what? Switched. Okay, if you run into something that's just looking ridiculous here, maybe try switching them around and see what happens, all right? But yeah, the antiderivative of sine, guys. Okay, I know I'm asking a lot to remember derivative, antiderivative, but what's the antiderivative of sine?
Negative cosine.
Negative cosine, okay? So if I go negative cosine, so this becomes the following, friends. Gosh darn it, Parsons.
Wait, why'd you make v equal sine?
So we assigned, the two that we assigned first was this one
Yeah.
and this one. Because that's what the formula says to do first, assign u and v prime. So to work backwards from v prime, this is the derivative of some function. I had to do the antiderivative to figure out what v is. Okay, so the ones that I knew came from the problems when I separated them. The ones I didn't know, what's the derivative of u? Well, that's the derivative of x, that's this one. What's the antiderivative of cosine? It's this one. And once you establish those four, it just becomes a matter of plugging stuff in over here on the right side. Okay? All right, so talk to me, my friends. This becomes x times the sine of x. Okay, you said minus, did you say negative cosine there, Kate?
Yeah.
Okay, minus a negative right there, that's gonna turn this into what? Guys, on the right side of the formula, is the integral sign gone now? Okay, so have I found an antiderivative completely if I've gotten rid of all the integral signs? Absolutely. Okay. All right, let's try part B together. You guys want me to show you what would have happened if I would have picked it the other way around real quickly?
Yes.
Okay, I'll put it over on the board. I won't put it in the notes, but I'll put it over here on the board. Okay, so what did we say u was originally then? X?
Yes.
Yeah, if I would have said, okay, that would have meant then u is equal to what? Cosine of x? Which would have meant then u prime is negative sine of x. And then v prime would have just been what? X?
Yeah.
Which would have meant that u was equal to, oh gosh, help me, 1/2 x squared? Okay, so this would have become u times v then. I'm sorry, yeah, u times v. Oh, this should be a v right here, not u, right? Good God. I'm driving a Ford this morning.
Hey.
Okay,
No,
hey, I
shit.
knew someone was gonna fire up. All right, u times v, wouldn't that be 1/2 x squared times cosine of x to start? Right? And then this becomes minus the integral of u prime times v. So this would have been negative 1/2 x squared sine x. Guys, does this part right here look like kind of a simple antiderivative or not so simple?
That's just.
Okay, let me kind of give you a general rule, and I'm gonna go completely probably against everything I just said here, but in a situation like this, if you get to be something that's pretty complex right here, pretty good chance that you're off on the wrong foot here, okay? Now, there's gonna come times right here when we get some of this done, we're gonna have to take this part and use integration by parts again, and I'll show you those examples, but how do you feel about that?
Good. Decent.
You see the difference between what the integral was right here and the integral is right here now? And which one would probably be nicer to work with?
No.
Okay, all right. Well, let's check out another one. Let's go through our helpful hints list again, see what happens. Okay, guys, look at your helpful hints here first. Go back to the first page of your notes. You're gonna help me determine. Okay, it said hint, look for what first? Okay, natural log there. Is there any natural log there? No. Okay, how about, what's listed second? Inverse trig functions? That's not there. Is polynomials the third one?
Yeah.
Is there a polynomial there?
Yes.
What is the polynomial part, really? It would just be the x, right? So let's start with this one. Let's let u equal x, which means v prime has to be what, kids?
E to the x.
Ooh, this is going to be an interesting one.
Uh,
What's this make u? Prime, I should say.
1.
What's a v then? What's the antiderivative of v to the x?
E to the x.
Okay, here we go. The antiderivative of this is going to equal the following. Do we have our 4 parts up here? Now again, this may or may not be right. If it's not right and you run into troubles, do what with your u and v prime then possibly? Switch them. Let's try this. Okay, it becomes u times v. So what, kids? Exactly. X times e to the x to start minus the integral of u prime times v. Okay, yeah, it's 1 times e to the x. Oh, I'm liking this one. Is that a pretty simple antiderivative over there on the right as part of integration by parts?
Yeah.
You betcha. What's the antiderivative of e to the x? So we're going to call this x e to the x minus e to the x plus some constant c. Now the way your book might show solutions when you're checking solutions, they might factor in e to the x out. I don't know if they will or not. But they also might call it e to the x times x minus 1 like that. I have no idea, plus some constant c out here. Make sense? I just factored e to the x out there. Okay. Guys, integration by parts is typically tough for kids. Understanding that it's basically an antiderivative of product rule. You see how we're coming up with this stuff here to start?
Yes.
Okay. Let u equal something, let v prime equal something. Use those helpful hints to try and determine what u is and work your way through this. All right? Let's try another. Everybody have what they need right here? Put an or up here and then I'll box it in. That way Robert can't say I didn't box out.
Haha.
You like that one?
That was funny.
Ooh, I see something in part C. You may see something in part C?
Missed that. Oh, natural law. Ugh.
All right.
Yeah. What do you mean it's a natural law? I've never seen Carson so happy to see a natural law.
What are we probably going to let u equal according to our helpful hints?
Natural law.
So that means v prime will equal what?
X squared.
All right, talk me through this. What's that going to make u prime? You guys remember the derivative of natural log of x?
Isn't it 1 over
1 over
x?
x. Very good. And then how about the antiderivative of v prime?
X cubed.
Okay, so is it okay if I just call it 1/3 x cubed then? Okay. Do we have the necessary ingredients to bake this integration by parts? All right. So let's add in a little bit of uv. So we're going to start out with a little bit of what times what?
With natural log of x times 1/3 x.
Yeah, and I'm going to put this numerically out front. I'm going to put the 1/3 out front. Is that okay? So it doesn't matter which order we're really multiplying in. So I'm going to go 1/3 x cubed times the natural log of x. That's the uv part then. Are you okay on that? Okay, so I've got this part. And then this is minus the integral of u prime times what? What's u prime equal?
1 over x.
Okay, 1 over x times really x cubed over 3, right? Now guys, does this integral look a little more complicated than what we've seen so far? But is it really that more complicated? I don't think it is, because we can simplify this a little bit. What would this x do to one of the x's here? Okay, so isn't this really the part that's on the left, 1/3 x cubed times the natural log of x minus the integral of, could I call this 1/3? Can I move the 1/3 out front? Is that okay, kids? You understand that's there. What's x cubed over x going to be? So the part that we're looking to really find an antiderivative of is x to the second there. What's that gonna become? Thinking derivative, go antiderivative, so up on power. X cubed over 3, you bet. So this is gonna end up as follows, kids. This is gonna end up 1/3 x to the third times natural log of x, that's our UV part, minus 1/3 times, you said x cubed over 3, right, Maddie?
Yeah.
Okay, so what am I gonna probably simplify this part to right there? What would the 3 times 3 get you down here? So I'm gonna say final answer, 1/3 x to the third natural log of x minus x to the third over what? Guys, when it works out nicely, you can find that antiderivative on the end. It's actually not that bad to do this. One of the things that we run into characteristics wise is some people will mess up like going from u to u prime or v prime back to what? V. So I told you already, I said, if something doesn't look like it works out, do what with the u and the v prime? Switch them. But if that doesn't work out either, check to make sure you've got your u prime right and your v right after you assign both u and v prime. That might be a good thing to do, okay? Letter D up there, I'm not really sure why they did that. That's very simple. It's just what? 1 over x, right? I think there might be a typo in that. Probably wanted something else with that. So let me double check. There might be more to that problem.
No, I say we leave it alone.
You say leave it alone.
I like that.
Yeah, you would take shortcuts, wouldn't you?
Yeah?
Hang on a second, kiddos.
Nah, I believe the shortcuts are 52, man.
Yeah?
Should have taken it.
Oh my gosh, you guys, I would have.
We all wanted easy senior year.
And listen, you guys are doing the right thing, trust me. You are doing the right thing.
Well, there's one easier, so there's something easy.
Yeah. Maybe applied math.
Yeah, applied math.
I don't think that's easy. Just the same.
Yeah. Guys, I'm gonna change that example up there. I'm gonna change it, we'll look at one more here. I think we're covered pretty good here. I wanna change this here, I wanna see what this looks like, okay? We're gonna change this to the integral of sine squared of theta d theta. Okay, we're gonna try and use integration by parts for this. We'll see what kind of a mess we can get ourselves into. You okay with that? Okay, this is actually kind of a messy one, all right? So I might put maybe just like a face like this. It's like, this is kind of tough. All right, here's the deal. In something like this where I have a trig function that's like this, it says sine squared of theta. So that really means take the sine of theta times what? So this is really the integral of sine of theta times sine of theta d theta. Now we're going to try to use integration by parts. I love this one to set up because I'd probably let u equal what? And what are you going to let the b prime equal? Okay, so I'm going to let u equal sine of theta. We're going to let v prime equal what, kids? You guys okay with that?
Yeah.
Okay, what's this make, what's u prime then? What's the derivative of sine?
Negative, or cosine.
Cosine theta. What's the antiderivative of sine for v?
Negative cosine.
Yeah.
Okay. Do I have our 4 parts assigned already?
Yes.
Okay, so here we go. The first part is what times what? This integral will equal, pull it down here. This is gonna equal what? U times v.
Sine theta times the negative cosine.
Okay, so I'm just gonna call this negative sine theta, cosine theta like this, so multiply, that's the u times v part, minus, okay, this is where things can get a little interesting. Oh boy. I think we picked a doozy. U prime times what? U prime times
V.
v. Oh boy, I don't know if I wanna do it this way. Okay. So this is minus the integral of what?
Cosine theta.
Cosine theta times what?
Negative cosine theta.
So this is like negative cosine squared of u theta again, right? Guys, what did we start by integrating right here?
Sine squared of theta.
Sine squared of theta and,
Negative
oh boy. We're kind of in a mess, aren't we?
Yeah, a little bit.
Okay, because if I'm finding an antiderivative for sine squared, we start out with parts, aren't I gonna kind of do the same thing with cosine now? We are, aren't we?
Yeah.
So, in this situation right here, is this looking like something that's messy, or is this looking like something that's gonna be pretty easy?
This looks kind of messy.
Yeah, it'd be nice.
Okay? It's gonna be messy, isn't it?
Mm-hmm.
Okay? Well, ugh. I picked maybe the most ridiculous problem in the world for you to do.
That's okay.
I'm telling you, we can always go back to where it was.
We could.
I'd rather do the same notes than on my own.
Okay, watch this right here. This becomes a negative sine of theta, cosine of theta, minus. Okay, this is really gonna, this negative 1 could move up front, couldn't it? Okay. I'm gonna take you back to some trig days.
I never took training.
Uh-oh.
Trade everything but trade.
Anybody remember this identity?
Eagles tank.
Oh, 1.
1! Yeah, it's a unit circle thing, okay? Maybe jot this down by that, at the very top of this one. Write that down. Okay? First 3 that we looked at were pretty easy, weren't they?
Yeah.
What about this one?
Not so easy.
Not so easy, okay?
Could have been easier.
We have an integral of a cosine squared, right? So check this out. If I want to get cosine squared alone here, cosine squared could equal 1 minus what? Okay. I can replace cosine squared with what? Here's where we're at right here. Okay, so go back to that previous page there. Watch what we do. This is gonna get fun. Kids, what we have right here is this. We are at the following. We're saying the antiderivative of sine squared of theta is equal to negative sine theta cosine theta plus the integral of really cosine squared, right?
Yeah.
But isn't that really gonna be 1 minus the integral? Or 1 minus sine squared theta, isn't that right? So that's like the integral of the following. Watch this, 1 minus. Okay, again, we started out with the integral of sine squared of theta, didn't we? Okay, hang in there with me.
I'm trying to do this.
This is the original problem, isn't it? Integral of sine squared of theta d theta. That's gonna equal negative sine theta cosine theta I can integrate this, I can break this into two parts, can't I? So it's really plus the integral of one minus the integral of sine squared theta. Oh, gosh. Oh, but wait a second. Can I find the antiderivative of one? What's the antiderivative of one?
0. Wait, no.
Other way.
X.
X, but in case on this one, instead of X, we'd probably call it a what? Theta, okay? How about we're back to an integral of sine squared again, right? Isn't that what we're trying to find right now? Okay, here's the kicker.
Oh, no.
We're almost done. Sometimes if you can get stuff to match, see on the left here? Kind of matches this part right here. Okay, watch this right here. What I'm going to do, I'm going to get rid of this by, what's the inverse of subtraction? I'm going to add this to this. So how many integrals of sine squared of theta do I really have over here now if I add that?
2.
Okay, watch what happens here.
0.
We get two of these, right?
It's 0.
Times the integral of sine squared theta equals negative sine theta cosine theta. You said the integral of one was what? You guys agree with that right there? Oh, I forgot the squared up here, didn't I?
That's pretty important part, man.
This is, I did. I talk a good game, and it's kind of like telling the punchline of a joke before you can get the joke out of your mouth, right? Okay, guys, what are we trying to solve for here? What was the original problem?
Somebody help me remember.
The antiderivative of just what?
Sine squared of theta.
Guys, could I get just sine squared of theta alone over here somehow now?
Can you divide by 2?
I could divide by 2, and we would say if I divide by 2, it goes away here, right? And so if I put this all over 2 right here, doesn't that go away here? So do we now have an integral for sine squared of theta? Are there any integral signs left over here? Okay, so we talked about this right here. It can be easy, can get kind of difficult. If you can't make an integral go away, try to see if you can't get an integral like this to match what you're actually trying to integral for, and combine them over here on the left side. Okay, that's a tough one. And like I said, we're not gonna spend a ton of time on this stuff. You know, we'll probably see about 4 or 5 problems on this stuff here, but I think that's a good place to stop today. Okay? You all have your notes down then?